Howdy everybody, and welcome back to our little display manager tutorial series. So last time we created a display manager that lets us resize our window so that we can have a game that is, well, that matches the size of our screen, or it could be bigger if we really wanted to, or it could be smaller. But there's one problem with it. There's a lot of problems with it, but there's one main problem that we really need to be aware of, and that's that our game size is pretty much matching our room size. So our game is the size of our room. This room is 1024 by 1024, and if we want things to match properly in the window, our window has to be a multiple of 1024 or 1024. Otherwise we'll get bars on the side. But what if we wanted to say have a different size room? What if we have a 1024 by 1024 room, but we want our game to match the resolution of our monitor? So our monitor here is a 16 by 9 monitor. Well, 1024 1024 is a 1:1, so that's a 1 ratio, and that certainly doesn't match that. So we're going to want to create what is known as a view. We're actually going to create two things, a camera and a view. And they're going to work together to let us resize our game however we want in such a way that we can then resize it to whatever screen we have we can match it to whatever screen we are using. So let's get cracking. So we can do this a couple different ways. We can come over here in our room. Let's move these properties up a little bit to make more room. We could come here and we could say viewports and cameras, enable the viewports, and make our viewport visible. There you go. And then we can change our camera properties and our viewport properties here. However, I don't really like doing that so much. I prefer to set this all up programmatically rather than using this built-in system. That way, you don't have to remember to do this for every single room that you go into. It just automatically does it because it's built into the display manager. So remember last time I told you to mark this as persistent, and that's because that will make it carry over from room to room as we move throughout our game. And the main reason for that is because we are going to add a new event here, room start. And with this room start event, we are going to, let me transition to my zoom. There we go. With the room start event, we are going to make our camera. So, it'd be better if I didn't have my hand off-centered by one key. Region, camera, and in region. Recreate the camera whenever a new room starts. And I kind of use cameras and views interchangeably because we're going to set this up so that the cameras and views work together as kind of one object, and you're not really going to see much of a difference. It doesn't really make much of a difference between them. However, when you start trying to do custom animations for making your view move around or your camera move around to change for cutscenes and for doing zooming effects and stuff, you'll have to separate them more. You have to separate the functions. But for now, we're just going to do this. If not, instance underscore exist. Because, cameras are really their own complete different topic because there's so much to go about on them. So I'm not really going to go into it very much. Object underscore. I wish it would actually pay attention to that little thing that says, don't show this ever again. Because it always shows it again. Anyways, object camera. So we need to create a camera object. So if we come back over to transition so that you can see what I'm doing, create an object, object underscore camera. And this camera object is not the same as this camera. This camera will be following the camera object, but it is not the camera object. So I hope you get that difference. And we're just going to do a step in step, and this is going to be really simple here. Let me transition back. Let's set up our camera first, and then I'll introduce you more to the functions here. So we're going to want to do view underscore camera 0 is equal to camera underscore create. View underscore enabled equal to true. View underscore visible is 0 is equal to true. And that's basically doing by code the exact same thing that I did here, except now it'll do it in every single room, and we won't ever have to worry about any of that about clicking the properties. So we need to set the size of our camera, and we're going to go with view underscore camera is 0. And we're going to want to create some new properties here. View underscore width, view underscore height. Now, typically, these will probably be exactly the same as ideal width and ideal height, but they could be different. So I'm going to set them over here. Because later on we'll add in some pixel perfect information that will allow you to that will dynamically try to resize your view for you whenever you're running on a monitor that isn't exactly the same size and aspect ratio as your view. So that'll all be useful there. View underscore set H port, view underscore camera 0, view underscore height, and view underscore set underscore W port, view underscore camera 0, again view underscore width. Now these two properties you need to set because they will determine they'll be important if you want to set up zooming for your camera, and if you don't set these up, I mean the camera and everything will work just fine without having these in there at all if you're not doing any zooming. But if you want to do zooming, then you have to have these things set up originally, or else you'll end up with a weird camera resizing issue on the first time you zoom in a game. Camera underscore set underscore view underscore position. Now this is going to be the most important one for us here. And 0, 0. That will set where our camera is actually in the room and where it's moving to. And we'll be using that over here in a second as well. And instance underscore create underscore layer XY. Doesn't really matter where you make it. Instances object underscore camera. There we go. That's creating our camera. And we'll come down here to our camera, and you want to do this in the in step because you want to move your camera after you move your player. If your camera is following your player, you want to move your camera after any sort of movement that it is following has been completed. So typically that would be in an end step. So just over here, we'll say if instance underscore exists object player So if a player object exists, then x is equal to object underscore player dot x, y is equal to object underscore player dot y, and camera set position to my x and y. And this will carry over its own problem as well, and I'll show you that in just a little bit too. So, but that should be enough to get us to our to about where we want to get on a camera. So what does a camera do? A camera allows us to unlink our game from the room size. So instead of 1024, now we want to determine how large do we want our camera to be. So let's see, we come back here, and 1024 describes the entire room. Well, we probably only want to be able to see this much of the room in one go, right? So that'd be like 1024 to 512, right? And then 512. So let's just do 5. Well, let's see. 512, and let's go with 256 just to make it really weird. Well, no. We'll do 512. And now that we have that set up, we can then add in, let's make sure I got everything set up here. So window underscore set size. So this will set our width again to 512, and everything else. So let's see what. Yes, this is already in the room, so should be good. Yep. So there you see, we now have just a 512 by 512 slice that has been zoomed up because we had 512 to 1024 because it found our zoom was possible to be a 2. So 512. And as you saw, we were just getting like the little corner of the camera is the 0 point on the window. So that's the actual position. And so what we need to do is add in some camera offsets to our positioning so that we will actually be centered on the player rather than having the camera be cornered on the player. So what we want to do here is to our X, since we were right there, we want to move to the left somewhat. So we are going to subtract our camera underscore get underscore view underscore width, view underscore camera 0, and multiply that by 0.5, or you can divide by 2, whichever way you want. Some of those. We're actually going to do about the same thing over here to our Y. Except now you are height. And with our Y was all the way up here. And we want to move our Y so that we are up higher. So that means we want to go lower in our Y axis. So Y minus the view height times 0.5. So let's give it a try again. There we go. Our player is now centered in the room. And you can see there's some small artifacts. So these artifacts are caused by the fact that the player is at the edge of the world and we are not clearing the background. So the background becomes persistent there. So we probably want to clamp our view so that the player can't see outside of the room. That way they don't see this problem. However, if you don't care about the problem, you can also enable background clearing, which will get rid of that so it'll just show black as the background. Or you could even set it up so that you have a big wide wallpaper for the background or something like that. So let's just clamp this camera view. And let me pull up my code for the camera. Here we go. So if we go all the way, and our X as well. So what we're going to do here is limit the actual position this camera object can be in. And we're going to go to clamp our X and Y position to view underscore width underscore half and room width minus view underscore half. Yeah. So that would be this. View width half is equal to we can get rid of that. And view underscore height underscore half is equal to this. Width underscore half, view underscore height underscore half. Need that there. And this, since we're not changing our view size all the time, can just be set in the create. That way we reduce the amount of calls because we don't have to figure that out every single time. And there you go. Now the camera can't move outside of the room. And our player is good to go. So now, thanks to this, we can now change our game size to whatever we want. So this game is rather big, so it's kind of hard to say. So let's see here. Let's see. I want 1920 by 1080 would be what is it? 640 by 320, I think, is the 20 times 4. That'd be 480. Divided by 6 would be 320. $180. 640. And 360. That's what I was looking for. That'll give me a 16 by 9 aspect ratio. As you can see, whoops, it zooms all the way, fills the entire screen there. Actually, you can't really see it because you're zoomed in. So let's zoom it out so you can actually see. There you go. Yeah. There we go. Now we are zoomed in to fill our entire screen. Isn't that what we wanted? Now we can actually play full screen. Well, it kind of works, but it doesn't solve every single issue we have. It's like, what if we had a game that is, I don't know, what if we actually wanted to be a little bit higher? What if we wanted it to be 640 by 520 for whatever reason. Well, we're not going to zoom in to fill the entire screen because we're not going to be able to fit. So we're going to need to add in our pixel perfect information to be able to dynamically switch our game up so that it will be able to fit the entire screen. And we'll get into that next time, but thank you very much, everybody, for watching. Let's see. If you have any questions, again, don't hesitate to ask. I have a Discord channel that's linked in the information, so you're always welcome to ask questions. Leave comments. I'd like to hear what NES game you'd like to see next as a tutorial. That'd be a fun thing to hear about. If you have any suggestions for future topics for GMS2 fundamentals, that's another great thing I'd love to hear more about. And just love to see your smiling face. So again, thank you very much for watching, and good luck with your coding.